it look somewhat familiar to you?
Yes.
Okay. And so what we want to do is to take a look at some of the other stuff. We want to take a look at vectorinc.c because I mentioned that there's a problem with it. Can anyone spot any problem with this file?
Yes, at the very end of that instruction, right?
Okay, all those
You don't do it,
pointers,
you need to offset some of those.
they're not casted. Okay, all of these addresses, they must be casted. But at this stage, it won't even make. Okay, if I say make vector inc, which is the executable name, it will not succeed. Oh, it does. Why would that succeed?
What do we do now?
Is it possible that it did not try?
Because of the timestamp issue.
Yeah.
You are correct. It might have done that. There we go. It's still.
Make clean.
Yeah, I have to make clean because the .o file is still around, so it's
Yeah.
relinking to the executable. So, does make clean up this one too? Yep, it does. No, it does not. That one is still around, so you have to.
You didn't do it by yourself.
Don't do a star here because if you do a star here, then you would have removed the original one. Then you have to retrieve that from the tar file again, which you can. It's just one extra step. Okay, so we'll make the executable again, and this time it will complain because we have a mixture of pointers. We have an int pointer mixed in with a struct vector pointer. You cannot do subtraction when one pointer is a pointer to an int and the other one is a pointer pointing to a struct. Okay.
Right.
So the program is not even compiling at this point. So you have to fix that first. That's a pretty easy one to fix. So you go to vectorinc.c, and then the way to fix it is simply to cast everything to char pointers. So we have char pointer here, char pointer here, char pointer here, and char pointer here.
Is
Okay.
there a problem if you cast it to anything else, just so I know?
Sorry?
You said, will there be some sort of problem if you casted it to something else?
Yes. Yeah. Char pointer is your
So
base
you just
size.
had to know initially that you needed.
If you consistently cast it to something else, then the size will be in the unit of whatever you cast it to. In other words, if you cast all of them to int pointers, then it will be showing the sizes in 32-bit chunks. In how many 32-bit chunks it will require. So it will still be wrong, okay, except it will compile. That gives me an idea for the actual exam questions.
Cool.
Yeah.
Now we know about that one. Now it's an easy fix. Go
But
ahead.
now I know you guys expect that one, so I know what to do about that too.
Are
we trying to do
Here
this
comes
mail or?
the shoe drinking.
Okay, so there we have the vector inc. So one thing you do want to do is just to do a sanity check and see whether it makes sense. Seems okay to me. Yes.
Yeah.
Okay. So that problem is fixed.
What did you do
Wait.
to?
Where's the integer? You didn't have the integer in there.
The integer?
Without an integer,
There's only
two
two
vectors.
elements. How many elements are
I
in
thought
this
there was
struct?
3 elements.
No, there are two.
No, only 2, the 2 vectors. Right,
Yeah,
okay.
Excellent.
Yeah,
Okay.
2D. Yep.
I'm sorry, what did you do to compile the inks.c program? You delete the object file first, or?
You just say make vector inc, and that will make the executable. You can also specifically say, we want, vector.inc, and that will automatically do whatever is necessary to regenerate the include file.
Okay, thank you.
Okay, so this is the easy step. This part is easy. The difficult part is to look at vector init dot uppercase s and figure out, okay, what is the problem with this? Okay, the first part is to read the comments that I have left here, because it is here for a purpose. The implementation of this subroutine is a shortcut to the C version. Because we have to copy the local variable r to the space for the return value, we might as well just initialize the space reserved for the return value. Is that making any sense?
No.
No? Okay. there are, okay, the inefficiency of doing something like this, remember what we talked about already of the efficiency issue? Is that first we have to reserve the space for the return value, which is enough space for the entire structure, right?
Yeah.
Then we have to extract a pointer pointing to that area and pass it along to the subroutine. And then what we do is we have a local variable called R or some other thing that is local to the subroutine, right? And then we initialize the local variable, which has nothing to do with what the caller can access. So the return statement in return will do a man copy to copy the entire structure from the local variable space to the space pointed to by
The return.
pointer, by the return value pointer. So that's a really, really long and complicated process, and there's a lot of allocated space that is wasted, really. So instead of doing that, why don't I just directly access the space that is reserved for the return value and change the members of the structure already in the reserved space for the return value?
Okay.
Yeah,
Okay, are you guys understanding, the quote-unquote optimization?
yeah.
So instead of going through a local variable R, I'm directly accessing and changing the space reserved for the return value. Okay, so that's the intention of this code, is to do that. So as with any type of code, in a question like this, you really have to question every single line and possibly comment every single line so that you can see, okay, this line is doing this, the next line it will be doing this, and so on, because you have to keep track of what the program is doing or what it has done up to this point.
Basically, you're going to be treating the return value as a pointer.
No,
Well, it's the address. You can't.
it is always a pointer. The return value address is always a pointer, except this time I don't copy into that space from a local variable. I just change that space directly, which is something you cannot do in C, because in C there is no pointer that gives you access to the return value address explicitly. You can probably calculate it and use some hack to get to it, but there's no explicit pointer that gives you the access to the space reserved for the return value. But in assembly, we know how to get to it.
No.
So that's why we can do it. Yep.
You know what passing by references for? So you know there's spot.
But passing by reference has its own little issue, because you cannot use passing by reference to no, it doesn't work the same way, because you cannot do what we can do with returning an entire structure when you use pass by reference. Okay, so this is kind of unique and something that we can do in assembly that will be almost impossible to do in C. Okay, any questions at this point? Questions at this point? So what we'll do is we'll go through the definitions, because there may be problems with the definitions themselves. Old EBP equals to 0, looks okay to me. Return address is old EPP plus 4, looks okay to me. How about x equals return address plus 4, x being the first parameter?
It should be
What's
like,
that supposed to be?
We're supposed to get the
Should be
return value address before the parameters. Okay, so what we need to do is to change the order a little bit. So we have the return value address to be right next to the return address. Okay, the return value address is right after, in terms of memory location, right after return address. And should we add vector size?
4.
Okay, so we change that to, a 4.